Hey guys! So our next lesson we're looking at is lesson 8. So it's more with Pythagorean theorem, so lots of practice with the Pythagorean theorem for us. Today specifically we are taking and finding missing sides in the right triangles. So we'll go ahead and jump right in. Remember to listen for our key word in this lesson and submit that on Canvas for credit. So what we have here is we are trying to find the missing side lengths. We're going to find C in the first one. In the second one, we're going to find B. And then in 3 and 4, we're going to have it wrote out, and we're going to have to take and solve for it. So I'm going to actually do this off my whiteboard. So I'll switch over to that, and we will solve for C. So as you guys know, the Pythagorean theorem is a squared plus b squared equals c squared. So let's write that out just as a reminder. A squared plus b squared equals c squared. So the a and the b don't necessarily matter. We could say that a is the square root of 40 or that b is the square root of 10. That's not as important as just making sure that your a and b values are the legs of the right triangle. Now in this case, it's telling us a is the square root of 10, b is the square root of 40. So we're going to have the square root of 10 squared plus the square root of 40 squared equals c squared. So the square root of 10 squared, the square root and the square cancel out, so we're just left with 10 plus, same thing happens over here, square root of 40 and squared, they cancel each other, so we're left with 40 equals c squared. Now we add the 10 and the 40 together, we get 50 equals c squared. How do we get rid of the square? We take the square root. So we take the square root, that cancels out, so c equals the square root of 50. And there's our answer. So this is all just practicing with that Pythagorean theorem and being able to solve for different missing side lengths. So you won't always be solving for C as you're taking and doing these. Sometimes you might be solving for A, other times you might be solving for B. It just depends on what the problem looks like. So for number 2, it's asking us to find B. So in this case, same thing. We have our a squared plus b squared equals c squared. Now in this one, it's not telling us specifically which side is which. All we know is the b is this side over here. So 8, the square root of 8 then is going to be our a because it's the other leg of our triangle. So we're going to have the square root of 8 squared plus b squared equals the square root of 26 is across from the right angle, which means it's our c squared. Square root of 26 squared. So just like up here, when we take the square root of something and square it, it's going to cancel it out. So we're left with just 8 plus b squared equals 26. So now to take and solve, we're going to subtract 8 from both sides. So we've got b squared equals 26 minus 8 gives us 18. So we've got b squared equals 18. Remember to get rid of the square, we take the square root. So b equals the square root of 18. So when solving for a or b, there's an additional step. We have to take and do subtraction. We have to subtract the side that we do have from the square of the other side to take and solve before we do the square root. Whereas up here, we're just, adding them together and then taking the square root. Okay? All right. Like I said, for 3 and 4, it's giving us words instead of an actual picture. Now, by all means, if you get confused by just having a bunch of words, draw out a triangle that goes with this. So it's telling us that this right triangle, so some right triangle, has side lengths of 2.4 centimeters and 6.5 centimeters. What is the length of the hypotenuse? So we're looking for the hypotenuse. So we're looking for our C, and the 2.4 and the 6.5 are our other two sides. It doesn't necessarily matter which one is which because the a and b can be interchangeable for values. So we're going to have 2.4 squared plus 6.5 squared equals our c squared. All right, so 2.4 squared is going to give us 5.76 plus 6.5 squared is going to give us 42.25 equals c squared. So sometimes, yes, if we have decimals in the original problem, we're going to have decimals in the end. So now we have to add the 5.76 plus the 42.25, and we get 4801 equals c squared. We take the square root. That cancels out that, so we end up with the square root of 48.01 equals c. So for this problem, we didn't originally have a picture, but it's perfectly acceptable to draw a picture if you need to see that to be able to solve. If you're fine with just reading it and plugging into the Pythagorean theorem, by all means, just do that. Either one is perfectly acceptable. It's just sometimes having that visual can be beneficial. So also remember, this is always right triangles. So keyword for this lesson is right triangles, because that's the only time the Pythagorean theorem works is when we have right triangles. So right triangle is our keyword for this lesson. And do write out triangle. Don't just try and put a triangle symbol for your answer. Okay. All right, the next question. A right triangle has a side length of 1/4 and a hypotenuse length of 1/3. What is the length of the other side? So I'm going to take and draw this out just so you guys can see it once again. So it told us the hypotenuse is 1/3, and one of the side lengths is 1/4. So we're missing, we'll call it B in this case. We're missing B. So we have 1/4 squared plus B squared equals 1/3 squared. Now, when you're squaring fractions, the square goes to both the top and the bottom. So 1 times 1, 1 squared, is just 1 over 4 squared is 16 plus b squared equals, well, 1 squared is 1 once again, and 3 squared is 9. Now we need to take and subtract 1/16 from both sides. So we end up with b squared equals, now taking 1/9 minus 1/16, we have to have a common denominator. So our common denominator is actually 144. So 144 is divisible by 9. We get 16. So this will be 16 1/44 minus, so 16 times 9 would give us 144, so minus 9 over 144, which gives us 7 over 144. So remember, when subtracting fractions, you have to have a common denominator. You can't just take and do 1 minus 1 and get 0 on that. The denominators are completely different, so that alters the problem. So make sure that you have common denominators to subtract. All right, our last step is to take the square root of both sides. So b equals the square root of 7 over 144. Now, 144 is a perfect square, but 7 is not, so we're not going to take the square root of the whole entire thing. If 7 would have been a perfect square, so let's say it would have been 9, we'd have had 9 over 144, then we would have taken the square root of both the numerator and the denominator. But in this case, being as it's not going to work out to be a perfect square for the top, we won't take and do the square root for our answer. All right, and our last question here. So find the value of x in the figure. So in this figure, we have kind of a lot of things going on, obviously. We've got multiple sides. We've got the right angle in there. We've got all sorts of things happening. Sorry, let me turn the page. Okay. So in order to take and find what x is, we can solve these two triangles separately to take and find that. So, or another way, since this large one is also a right triangle, we can take and solve the whole and then find the smaller part. So our hypotenuse is the x plus 5, but that might get messy, so we're going to keep it a little simpler. So even though this is a right angle, we're going to solve this triangle for this side, then we'll solve this triangle for our x. So it's going to be a double Pythagorean theorem. So for the first one, we'll name this y, just so we have a reference value there. I'm going to switch markers because this one seems to be dying on me. Second. Okay, so looking at the small, or the larger of the two small triangles right here, we have a hypotenuse of the square root of 34, we have a leg of 5, and another leg of y. So we're going to have y squared plus 5 squared equals the square root of 34 squared. That'll cancel out, so we've got y squared plus 25 equals 34. We'll subtract 25 from both sides, so we have y squared equals 34 minus 25 will give us 9. And then we'll take the square root to end up with y equals 3. So this is going to be 3 right here. So now in this one, we're going to take and solve it. So we have the hypotenuse is the square root of 18. X is our a value, we'll say. 3 is our b value. So x squared, 3 squared is 9. So x squared plus 9 equals, remember, squaring a square root, that just cancels out. So left with 18. We subtract 9 from both sides. We end up with x squared equals 9. Take the square root. So x equals 3. So ironically, x and y in this one are the exact same thing. So that means this small triangle right here is an isosceles right triangle. So these two sides are the exact same value. But our answer here would be 3. So anytime we have a couple of triangles put together, there's a couple different ways. It just kind of depends on the information you have, which way you want to take and do it. In this case, the best option was to take and do the two smaller triangles to solve for x rather than looking at the whole and then subtracting away. It makes it a little bit easier on this case. But in other cases, in other cases, it may be easier to do the large triangle and then subtract away to find what you're missing. So it all kind of depends. So a reminder, our keyword is right triangle. And right triangles are what we can use the Pythagorean theorem on. It's the only kind of triangle we can use the Pythagorean theorem on to find missing side lengths. And the Pythagorean theorem is a squared plus b squared equals c squared. Remember, if you guys have any questions, office hours are Monday, Wednesday, Friday from 1 to 2. Feel free to get a hold of me. And remember, your keyword for this lesson is right triangles, so make sure to submit that on Canvas. Have a great day and happy mathing.